Hello, good morning again class. Welcome to our online class. So now we having our continuation about our previous lesson. In our previous lesson, we studied about what? What is our previous lesson? We study about gravitational force. So under gravitational force, we have mass and weight. So now, on this topic, by the way, you are all welcome to our online class. So I hope and hoping that you are enjoying watching this video. At the same time, you learn something from it. So now, under gravitational force, we have mass and weight. So before that, we have gravitational force. What is gravitational force? Because of gravitational force, everything is organized. Everything is synchronized. No cars float on the air because of gravitational force. No people jump on the building and stay on the air because of gravitational force. There's something on the ground that we are going that the people cannot stay on the atmosphere, on the air, and no boat or an animals floating on the air because of gravitational force. That's why because of gravitational force, everything is organized, everything is synchronized. That's the work of gravitational force that we studied last week. So that's the gravitational force, and now we having our continuation of our topic, and our topic for today is about mass and weight. Okay, mass and weight. By the way, in our previous lesson, we know or we learned that how to get the mass, or what things that we are using to get the mass of that object. You know that mass, we can get the mass of that object using electronic balance. Through this electronic balance, we know what is the mass of that object. Okay, so that's our previous lesson as well. And now also number 2, we get the mass of an object by using lever balance. By lever balance. So again, we use materials like electronic balance and lever balance to get the mass of that object. Now, can you see this picture? This picture is a trolley. We are using this one in the mall. Very common. We can see this one anywhere in the mall, right? So are you familiar? Yes or no? Yes, this is a trolley. This trolley is an empty trolley, meaning no things inside on this trolley because it is empty. And now the trolley is easy to move or change the direction. Imagine when you push the trolley is empty, it's easy to change the direction. The direction when you turn right is very easy to turn right. When you push going left, very easy because this trolley is empty and easy to move. Because why? Because this trolley is empty. But look at this picture. This picture same. This is a trolley, but this trolley have a lot of things inside. This is full of things inside. Then thus the mass of the trolley becomes greater, right? Because a lot of things inside on it, so that the mass of this trolley is greater. When it has matter in it, okay, when it's matter, meaning the things inside on it, inside the trolley becomes difficult to move or to change direction. Again, the empty is easy to move and change direction, but the trolley have a lot of matter or things inside on it, or already heavy because a lot of things or a lot of matter inside on it that truly is difficult to change direction and move. That's the different. Okay, the empty and not empty truly. So therefore, the more mass an object has, the more it resists change its motion. Motion meaning moves. Direction. Okay, so meaning that things, a lot of matter is difficult to change direction. It's difficult, but the things that no matter or empty, like a truly empty, no matter, is easy to move. Okay, I hope you understand on that. Empty, truly, or no mass is easy to move and easy to change direction, but truly have matter on it or things on it, a lot of grocery on it, it's difficult, it's hard to change direction and to move. That's the difference between the two. Look at this also, these two cars. Number one, this car is small one. Small car, okay, compared to this big car. Now, I'm just asking you a question. Which vehicle can change its direction easier and quicker? Which one? This one or this one? Which one? Which vehicles that is easy to change direction and easier easy to move? Of course, the smaller one, right? This is easy compared to this big, okay? Because this big vehicle, a lot of mass inside on it. A lot of mass because it is bigger vehicles. That's why it is hard or difficult to move and change direction compared to this vehicle, because this vehicle is lesser mass than the bigger vehicle. I hope you understand on that. So that is mass. Now let's proceed to the weight. Weight is the weight of an object measure how much gravitational force is acting on it. A spring balance and compression balance can be used to measure weight. Its unit is Newton. So in getting the weight of that matter, we are using spring balance. The mass, we are using electronic balance and lever balance. But in the weight, we are using spring balance. This one, long time ago, I saw this one when I'm still young, but now only rare people using this one. But commonly we are using compression balance. This one right now we are using compression balance. Okay, so that's the things that we need to do, or we need to use when we get the weight of the matter. Now, in our topic about mass and weight, a lot of example. Next example is this one. This is a football ball. I know you are familiar with this because Thai people is fun playing football. So this is the football. Okay, imagine football ball. This is a football, and this is the bowling ball. Football ball and bowling ball, same size. Okay, the same size, the same matter. But this football ball is, the football and the bowling ball are similar in size. They were the same size. And however, the mass of the bowling ball is more than that football. Okay, the mass of the bowling ball is more than on that football. The mass, because this is heavier. than the football, but the same size. Same size. Okay, the same size. The amount of matter in the bowling ball is more than the football. Try to hold the football. You can hold the football and the bowling ball. Okay, this is a football ball and the bowling ball. With your hands, can you feel that downward force in the bowling ball stronger than the football? Okay, when you hold bowling ball, football, you can feel that your hand is falling down heavier than a football, because this one is heavier. But imagine the same size, but this is heavier. That's why your hands falling more than this football. On the earth, in our earth also, that's an example. Okay, football and bowling ball. So now in our earth, an object of 1 kilogram equals to 10 Newton. In our earth, Philippines, Thailand, anywhere in our earth planet, okay, 1 kilogram equals 10 Newton. Imagine that one. 1 kilogram equals 10 Newton. The mass on object is the same everywhere. The mass, okay? The mass of the object. Example, apple. This apple is 1 kilogram. When you go on this earth anywhere, this same 1 kilogram. In Thailand, you try to get the mass of this apple. The weight is 1 kilogram, or the mass is 1 kilogram. When you go to America, the same apple, you weight same 1 kilogram. When you go to Philippines, the same apple you put in the scale, same 1 kilogram. Okay, because the mass of the object is the same everywhere. Same 1 kilogram in Thailand, 1 kilogram in America, in Japan, 1 kilogram in China, the same, because the mass cannot change. Okay, but however, the weight of an object changes from the place to place. From place to place. Imagine, example, again, example, 1 kilogram equals 10 Newton, but the mass of an object, things, okay, chair, apple, anything, object, anything, is the same everywhere, same. Okay, 1 kilo in Philippines, 1 kilo anywhere. But the weight of an object changes from place to place. What is place to place? From Earth to Jupiter. Example, in Earth, in our planet Earth, 1 kilogram of apple. In Jupiter is not 1 kilogram. It changed because of gravitational. Example, in our Earth, we have 10 kilos of rice. 10 kilos of rice. But this rice, 10 kilos of rice, we are bring this one and we are going to travel, going to the moon, not earth, not earth. We travel going to the moon, bringing this 10 kilos of rice, going to the moon. The 10 kilos of rice from the earth going to the moon is not 10 kilos anymore. Why? It changes because the weight is changes place to place, because another place is another gravitational. Example, look at this picture. Look at my background. On earth, on our earth, mass of 48 kilograms. Example, we have an object or mass have 48 kilograms. So on weight, because we are using mass 48 kilograms and weight is 480 Newton. Look at the picture. Okay, on earth, mass 48 kilograms equals weight is 480 Newton. That's it. That's in our earth. But when we proceed to the moon, another place, we travel to the moon. From the earth, we travel to the moon. the 48 kilograms weight can change in ET in moon. What is the reason? The reason is the moon gravitational force is weaker than Earth. Again, the reason, the moon gravitational force is weak or less than or weaker than the Earth. That's why the moon's gravitational force acting on the person is lesser. Therefore, his weight on the moon is lesser compared to weight on Earth. That's the reason, because the gravitational force in the moon is lesser or weaker compared to the Earth. That's why mass 480 Newton in the Earth become 80 Newton on the moon, because the reason is the moon is weaker gravitational than the Earth. Understand? So I hope you understand. Now, I have an activity. I hope you understand our lesson. Our activity, you can answer this question. I give you 5 minutes. You are going to answer this one on your notebook, and next month or next meeting, I'm going to check that one. So I hope you enjoy answering this question, and see you next meeting. And bye-bye for now.